today we're going to learn about angle relationships and parallel lines. And one of my favorite things is Pythagorean Theorem. Learn about that today, and the distance formula. It's a whole bunch of stuff dealing with some lines. So first of all, I pre-drew this as pretty as I could, which was actually pretty amazing. So I'm going to teach you, first of all, what lines, like what angles are, because there are certain angles in these that you might need to know eventually. So this line right here, this line, that is called the transversal. It cuts two parallel lines, just cuts them. Whoop. So there are certain definitions of angles. So we're given, I'm going to write them down, and I have different colors. So there are alternate interior angles. There are alternate exterior angles. There are corresponding angles. And linear pairs. And vertical angles. So looking at these, when you look at something like this, when you're given this problem, there are two alternate interior and two alternate exterior, pairs. With corresponding linear and vertical, in something like this, there are 4 of each. So now let's find them. I'm going to label my angles here. There goes a marker. 1, 2, 3, 4, 5, 6, 7, 8. So, let's find, first of all, our 2 different alternate interior angles. So alternate interior means you're inside, and they have to alternate. So alternate interior for our first one would be 3 and 6. So angles 3 and angles 6 are alternate interior. So if we know that angles 3 and 6 are alternate interior, what would be our other alternate interior? Well, how about angles 4 and 5? So by coming to that conclusion, these are our 2 sets of angles that are alternate interior. So now looking at that, well, now we know how can we find our alternate exterior. Well, that means they're on the outside and they're alternating, which means we get angles 1 and angles 8. Should have used a different color. I have one. Angles 1, angles 8, and then angles 2. That's not how you write it, too. Angles 2 and angles 7. Hang on. So those are our alternate exterior. So, cool, huh? Right? Now we're going to find our corresponding angles. Corresponding means they're angles that are on the same side of the transversal if I can speak, but in matching positions. So they're on the same side, but they're matching. So corresponding, there's 4 of them in each of these. 4. Corresponding means they're on the same side, so I know that one is going to be corresponding to, again, learn how to use a different marker. Corresponding. This is 1. We're going to take this guy and let's find his corresponding one. Well, his corresponding guy is 5. 1 and 5 are on the same side, same angle. Angles 1 and angles 5 are corresponding. Well, knowing that, there's 4 corresponding angles in something like this. So knowing from that, I'm not going to write them all down because it's going to get, the board's going to get messy. So knowing from that, we know that 3 and 7 are corresponding, 2 and 6 are corresponding, and 4 and 8 are corresponding. Because they're in the same spot, so they're in the same spot along the transversal, and they're the exact same angle. That's what they're asking for corresponding-wise. Okay, so now let's look at linear pairs. Well, linear pairs sounds relatively easy, right? It's a line. It's a pair of adjacent angles formed intersecting lines whose sum is 180. So a line, straight line, 180 degrees. So if we're looking at this, again, there's 4 pairs. It's a lot. I'm going to look right here and I'm like, well, 3 and 4 are on a line. So angles 3 and angles 4 form a linear pair because they're on the line. In the same aspect, angles 8 and angle 6 also form a line going that way. So if we have 3 and 4, 8 and 6, then we have 7 and 5. There's actually tons in this one. 1 and 2, something like that. So anything that forms a straight line, linear pair. Okay? I'm just trying to teach you like the basics of this because as much as they want you to know this, you're not going to know it. It's not on the worksheets as much. So with a vertical angle, vertical angles are opposite angles formed by the intersection of 2 lines. So they may have the same measure. So let's look at this. Vertical, well, what does vertical mean? Vertical, look. Right here. Your pair is 1 and 4. But then we also have one at 7 and 6. And then we'd also have one at 5 and 8 and 3 and 2 because they're vertical, right? Those are what vertical angles are. This is like pretty easy. I'm going to drop all my markers. So yeah, I like this kind of stuff. This is like basic geometry for me, and I don't mind this as much. I still need this. So you just have to learn how to classify these, and the classification is sometimes what gets kids. They don't like to classify the right way. Can you not? Stop it. Okay, so let's look at it a different way. I'm going to try to keep the drawing up as much as I can. Because I don't want to erase the drawing. So if you noticed on my line here, I have these 2 arrows. Well, this means that the lines are parallel, which is amazing because I like when lines are parallel. I'm trying to find the right color marker I want to use. So, if I'm given that this angle is 60 degrees and trying to find one here. So this angle is 60. And they want us to find, and this angle's x. And they want us to find out what x is. Well, we can do that by saying, well, we know that this is a linear pair, and linear pairs need to add up to 180. So basically what I'm going to do is I'm going to do, well, what's 180 equals x plus 60. That's what I have to do. This doesn't match, obviously. Minus 60, so x equals 120. So this angle equals 120. It doesn't look like it on here, and that's fine because I don't want to keep drawing stuff. But let's say it's not a parallel line. This is where sometimes it's not going to be parallel and you're not going to be able to figure things out. Trying to find something. Oh. I mean, if it's not parallel, sometimes you just can't figure things out. And that's just how it's going to be. And if it's not parallel, it just won't have these two lines. And sometimes it'll even look like this. You get a line this way, and a line this way, and then this. And then, obviously, that's not parallel, right? And then sometimes you just can't solve certain things that come out of that. Okay? That's pretty much the basic ideas of that. It's hard to do that on the board. It really is. Okay. I apologize for some things that are harder to do on the board. So let's move on to triangles, because this is the next step. We're going to move on to basic triangles. Angles in a triangle. Every single angle in a triangle, when you add them together, all have to add up to equal 180, no matter what. So if we're given this triangle, and this one says 2x, and we have 75 and a 75. We need to figure out what this angle is, or what x is, right? We need to know. How do we do that? Well, we know that every angle has to add up to 180, so each triangle has to be 180. Well, let's just do the addition. 75 plus 75 is 150. 2x 180, right? Minus 150. 2x equals 30 divided by 2. So x equals 15, but that's not what they asked us, right? So we know what x is, but what is that angle? Well, that angle is 30. So they wanted you to find x, and they also wanted you to find the angle. So the x is 15, and the angle is 30. So that is how we're basically doing these kind of things. See, these triangles are not too difficult. But what if we're given kind of a word problem? And it kind of confuses kids. So we're given the measures of the angle, or the triangle RST. Oh, it's not that high. Good job. So the triangle RST has a ratio of 2, 4, 9. So what's this saying? Well, this is saying that the angles are 2, 4, and 9. 2 by 4 by 9. So I know that each one has to add up to 100. Each triangle adds up to 180. Well, what I do is I take this and I don't know what the angle measures are. So 2x plus 4x plus 9x equals 180. Because I don't know what these angles are. They're just giving me the numbers that are in front of the x's. So now just add those up. 2 plus 4 plus 9. I don't know how I got. What did I do here? Hang on. I got like 5, and that was weird. 1 second. I think I wrote it down wrong. It's 15. On my paper I wrote 5, and I was like, what the heck? 15x equals 180. Let me make it. Okay, so 2 plus 4 plus 9 plus 15, and then we take this and go 15. I'm going to do 180 divided by 15, and we get 12. So x equals 12, but that's not what they want. They want us to know what are the angles in the triangle. So how do we do that? Well, I'm just going to plug the number back in. So our first one is R and S and T. That's usually how it goes. So angle R would be 2 times 12, which is 24. Angle S would be 4 times 12. My hand hurts. I messed it up the other night, which is 48. And then angle T is 9 times 12, which is 108. And then if you want to go back through and be like, okay, well, does that add up to 180, which it should, just add those numbers up. So just do 108 plus 48 plus 24, and you'll see it adds up to 180. So we did that triangle right. So if they're giving you something like a ratio, just do it like that. Right? So that's the basics of this. Let's do one more where it's kind of a little bit harder. Not too much harder. Tiny bit harder. Just a tiny bit. So they're giving us a triangle. Oh, this marker's dying. No. Hang on. I might have another black one. I have two. I just don't know how well they work. New markers. Hey, ooh, that's a nice one. Nice. My really good markers. Okay, so they're giving this. My triangles are lovely. Can you just tell how beautiful they are? Compliment me on my triangles, guys. They're awful, I know. Okay, so we're given something like this. Oh, it's not supposed to be a 5, it's supposed to be a 5. Ah! It's fine. Lost a marker. So we're given something like this, where we have x, 2x minus 10, and 52. We need to figure out what x is. Well, we know everything in a triangle needs to add up to 180. Oh, I'm going to kill that cat. Hey! Hey! Get out of there. So, you're going to do x plus 2x minus 10 plus 52. It's going to equal 180. Well, let's combine our like terms. I have an x and a 2x, which equals 3x, and then a negative 10 and a 52 equals 42, which equals 180, right? So now that we're there, now we're going to subtract our 42. So 3x equals, shoot, I didn't write it down. I did the work in my head and then didn't write it down on the paper, which is super smart. Always write your work down. 138. Once we get there, now we're going to divide. So divide by a 3. X equals 46. So we got 46, so we know that this angle's 46. But let's figure this guy out. So now let's plug that back in. Just do 2 times 46, and then minus 10. So this angle right here is 82. And if we want to check it, just do 46 plus 82 plus 52. And it all equals 180 degrees. Cool, cool, cool. So you can easily solve these if you know that every triangle has to add up to 180 degrees. Right? Yeah. I know. I'm awesome. What can I say? Okay. Oh, hang on. I'm making my craft room a mess right now. Alright, now we're moving on to the Pythagorean theorem. The Pythagorean theorem is an equation that will solve triangles. It's dope. It's probably one of the coolest equations besides the quadratic, which I'm not going to teach you guys. Not for a little bit, not until we get into college stuff. But the Pythagorean theorem states that a squared plus b squared equals c squared. What does this mean for us? Well, this means they want us to find the length of a missing side of a triangle. So we're given a triangle. Like this. And let me Has to be a right triangle. Okay, so we're given this as 8 and 7. We need to figure out this right here. I don't know what this is. So what we do is we're going to do the Pythagorean theorem. A is side 1. B is side 2. And C is the hypotenuse. I'm not going to spell this right, so don't make fun of me. Hypotenuse. Okay, well, what is the hypotenuse? The hypotenuse is always the longest side, the one away from the right angle. It's always this side. So this is side 1 and side 2. This is always the hypotenuse. It's always the side that's farthest away from the right angle. So if we're given this, we just need to plug it in. Well, 8 squared plus 7 squared equals c squared, because I don't know what my hypotenuse is yet. I don't know. So now let's do the math. 8 squared is 64. This is why you need to know your squares and your square roots, because you're going to have to know these off the top of your head. 7 squared is 49 equals c squared. Now add that up. You get 113 equals c squared. Well, we're not done yet. We have to get rid of that square. What's the opposite of a square? Square root. So to get rid of it, this is why we learned radicals. So the hypotenuse is the square root of 113. And if they want a decimal, put that into your calculator, and usually they say round to the nearest tenth. And in this case, it would be 10.6. If you can simplify the radical, simplify the radical. But you can't simplify 113. I already know that. So, let's look at another one. I like Pythagorean theorem a lot. It solves a lot of my problems in life. So let's look at one like this, where they're like, okay, so now we're giving you this triangle, where we have 10, A, and 5. Well, right here, they're giving us the hypotenuse, and they're giving us side B. They haven't given us side A, so now we have to do a whole different kind of solving. So we don't know side A, so we do A squared plus 5 squared equals 10 squared. Well, we know that we don't know A squared, but we know that 5 squared is 25, and that 10 squared is 100, right? So now, let's do our subtraction. Minus our 25. So A squared equals 75. And how do we get rid of a square? Square root it. So now we have the square root of 75. And we can simplify this. If you know, remember from last time, how many quarters does it take to make 75 cents? Well, 3. And each one is worth 25 cents. And there's our perfect square. So we're taking a 5 out and left with the square root of 3. So 5 square roots of 3 is what A is. And if they want a decimal, in this case it's 8.7. Right? So this is the basis of Pythagorean theorem. They're giving you sides, and you're just putting it into this equation. Just make sure you're putting it in the right way. Like if they give you C, make sure you're putting C where it goes. Stuff like that. So, this is why I like Pythagorean theorem. It's just, it seems to just make sense in my head. So this one, they're not giving me like, they're just not giving me like triangles, they're just giving me the things. So they're saying, well, this B equals 22 and C equals 25. Well, if I know those, I don't know A, so A squared plus 22 squared equals 25 squared. Okay? Well, let's figure this out. Well, A squared plus 484 equals 625. minus your 484. My 4's awful. A squared equals 141. Opposite, radical, square root. A equals square root of 141, and if they want it in decimal form, it's 11.9. It's really basic, simple math, just with added squares and some square roots. And you just need to know this. They say Pythagorean theorem, you know that it's a squared plus b squared equals c squared. All you need to know about that. So let's say we're given a word problem with that. So, I'm going to erase everything. So we're given a word problem. Who doesn't like word problems? I actually enjoy them now. I used to hate them, but now, you know what? I actually like them. So, trying to find a good one on here. So let's say that Tara is driving north. So she's driving north for 22 miles. And then she drives east. This is how I'm going to do this. East for 11 miles. And she wants to know how far she is from her starting point. Oh, it's a triangle. Look at that. So let's figure this out. She drove and drove, but we need to figure this part. So this part's our hypotenuse. So 22 squared plus 11 squared equals c squared. Well, 22 squared was 484 plus 11 squared, which is 121, equals c squared. Ooh, am I smart? I am smart today. Yeah, I am. Which is the square root of 605. Because I know that I have to take the square root. Sorry, I did a fast step and I apologize. Because I know that 484 plus 121 is 605, and then I knew I had to take the square root. I apologize for that. This one just says they want you to put it into decimal form. They just want to know how far she is. So the square root of 605 is 24.6. So that's how far she is away. It's basic deductive reasoning with word problems, honestly. I used to hate them, and now it's like word problems are probably some of my favorite things. So let's talk about something that sucks. Not really sucks, but you look at it and you're like, holy crap, why do I have to do this? This is ridiculous. So I'm going to try my best to draw one of these shapes, and you'll see what's happening here. Let's try this guy right here. So please don't make fun of my shape, because it is going to be not perfect. It's definitely not going to be perfect, guys. It's going to be awful. I apologize for that in advance. So let's say we're given something like this. Oh, it looks pretty okay. This looks fine. Not really. 3, 5, and 11. 13. And x. So say we're giving something like this. They want us to figure out what x is. Well, crap. We don't know. We're not even given any lines for this other triangle. So what we have to do is we have to do the Pythagorean theorem twice and then another time. So technically we have to do it 3 times to figure out what x is. So let's start with this bigger triangle, finding out what this is. So I'm going to do 11 squared plus 13 squared equals c squared. Oh my lord. So 11 squared is 121. I should know this off the top of my head, but my brain is not functioning right now. 13 squared is 169 equals c squared. So 121 plus 169 is 290. Okay, so here's what I'm going to tell you guys to do. So let's take our square root. My thing is, let's not take it out of the radical. There's a reason we're not going to take it out of the radical. So we know that this side is the square root of 290. Just leave it under the radical, and there's a reason for it in a little bit. So let's do this one next. So we have to figure this guy out too. So 5 squared plus 3 squared, that's not a square, equals c squared. That means it's 25 plus 9 equals c squared. 25 plus 9 is 34 equals c squared. And then take the square root, leave it under the radical. There are reasons we are going to do that. So now, this side is the square root of 34, this side is the square root of 290, and this is x. We need to figure out what x is. This is the reason I told you to leave it under the radical. I will show you. So, I'm going to erase these other ones, and we're going to move on to the third one. So, here's the reason why. We have the square root of 34 squared plus the square root of 290 squared equals x squared. Well, what's the opposite of a square root? Well, the opposite of a square root is squaring. So this is the reason I left it under the radical, because these will cancel each other out. So now I'm just left with 34 plus 290 equals x squared. That just made my work so much easier, because had you taken that out of the radical and simplified it, you would have had to put it back in, and it would have been a big mess. So I always recommend in these big shapes, leave them under the radical until you're ready. So 34 plus 290 is 324. Okay? Well, now we can actually take the real square root. Now's our time. So what is the square root? That is not what I'm doing. Hang on. I pushed a button on my calculator. Hey, there we go. Square root of 324. This is a perfect square. This is why you need to know your perfect squares. X equals 18. So we did all of that, like 3 different Pythagorean theorems just to get to what this was. And it's cool how it all worked out, right? I think it is. That's just me. But you can get this line by doing Pythagorean theorem twice and then a third time to get what that is. I like it. It's kind of satisfying when you get the right answer. Okay, so let's move on from the Pythagorean theorem. And we are going to move on to something called the distance formula. Now the distance formula is kind of another way to look at Pythagorean theorem. Is you can use it to find distances between points on a coordinate plane, but you can also use Pythagorean theorem to do that too. This is kind of a tiny bit of a shortcut. So the distance formula is written out like this. Given a radical, and you have x1 minus x2 squared plus y1 minus y2 squared. Okay, so this is when we're giving it on a coordinate plane, or they're giving us points. So that's our distance formula. So let's say that they're giving us this point here, and they want it as simplified radicals. They either want it as simplified radicals or decimals, either one. I'm probably just going to go with simplified radicals just to teach you that, because you guys can get the decimals yourself. Simplified radicals are kind of fun for me. So let's do this one. They're giving us 2 points. Our points is -2, -1, and 0, and 1. So we just need to figure out which to plug in, right? So I'm going to make this, I'm dying over here. I'm going to make this my x1. So this is my x2, and this is my y1. This is my y2. And we're just going to take these, throw them into that equation up there. Just chuck them in. So I have the square root of negative 2 minus 0 squared plus, oh, never mind, that was wrong. Negative 2, I did that wrong, guys. Hang on. Time out, guys. No, I did it right. I'm struggling. Take a breather. 5 seconds. Okay. I did it wrong, but then I did it right. Negative 2 minus 0 squared plus negative 1 minus 1 squared. Much better. I was doing it wrong. My brain was thinking other things. It was firing. Okay. So now let's just solve this. Negative 2 minus 0 is negative 2 squared plus negative 1 minus 1 is also negative 2 squared. Well, negative 2 squared is 4. Negative 2 squared is 4. 4 plus 4 is 8. So now it's the square root of 8. But we can simplify the square root of 8 as a radical because we know it splits into 2 and 4. And we know 4 is perfect. So we're left with a 2 underneath our radical and a 2 on the outside. That is the distance between these 2 points. If we were to graph this on a graph, that would make a line, these two. And then this would be the distance between those two. It's like a hypotenuse, pretty much. Cool. I like the distance formula. So let's try another one. I'm trying to frame this better as I do this, so just saying. Let's do one where we're given 2, 3, 5, and 6. Well, here's my x1, my x2, my y1, and my y2. But you can do it in any order, as long as they stay in the same order. So, square root of 2 minus 5 squared plus 3 minus 6 squared. 2 minus 5 is negative 3. Plus 3 minus 6 is also a negative 3. Okay, I'm not going to carry the radical down the whole way. I know that I need it at the end. So 3 squared is 9 plus 9, which is 18. I'm going to put it over here because I don't want to keep going down. So square root of 18. Let's see if we can take something out. Well, obviously we can, because there was a 9 in there, right? We can do a 9 and a 2. Well, right here is our perfect square. So we're taking a 3 out. 3 square roots of 2. That is the distance between these 2 points. I like the distance formula. It's pretty fun. I like Pythagorean theorem. I like distance formula. I love quadratic. Basic quadratics are super fun. They get even better when you get imaginary numbers. And then people look at you like you're crazy. But it's like, no, math made me crazy because there's imaginary numbers in math, and I love them. I lost my mind. It's fine, guys. It's totally fine. So, knowing that we now have the distance formula, who doesn't love this formula? Honestly, write these down. These are amazing. Because I wish I could give you guys all my little cheat sheet, because I have this dope cheat sheet right here. I have copies of them at my house, like tons. And they have what they have on them. Look at that. So they have the Pythagorean theorem and the distance formula. They have all of the angles and their definitions. I even have a geometry one when we get into the further geometry stuff. I mean, seriously, I gotta figure out a way. Look at this geometry one. Yeah. It gives you all of the freaking, like, here's how to do it. There's the formulas for them. Like, I need to figure out a way to get these to you guys, because that just makes everything easier. So, that's the distance formula and Pythagorean theorem. Fun. Fun, fun. you guys feel about that. I feel like I try not to move too fast through them, but sometimes I feel like I do. And if I am moving too fast and you want me to do another lesson on it and like use more examples, let me know in the comments and I'll do more lessons of these. I don't mind redoing lessons, they're fun. Just let me know. Thanks.